right, ladies and gentlemen, we're going to take a look at the second part of simplifying radicals, and this is where we take a look at fractions. If you remember from the previous video, I kind of talked about the first two rules, that there's no decimals and there's no pairs of factors. But what we said is there can only be one radical in the answer, and we saw that with the multiplication. We're going to see it now with fractions or with division. And now what we have is there can be no fractions in the radical, which is what we're going to take a look at here today. And then also no radical in the denominator of a fraction. All right, so let's take a look real quick. All right, sorry guys, I want to make sure I had everything in the right spot. We're kind of going to take you through these methods, and they're more of a questioning technique that you want to look at. So the first thing we could do, one of the methods we could try, is split up the numerator and denominator. If the denominator is a perfect square, so that's usually the first thing you want to check for. Is your denominator a perfect square? So when I take a look at the first one, we've got square root of 2 over 9. Well, I'm going to look at this denominator, and I'm going to check and see, is that a perfect? So when we take a look at this, 9 is a perfect square. So we're going to split it up into the square root of 2 divided by the square root of 9. Remember yesterday, or in the previous lesson, when we had multiplication, we put them under one radical. We can do that whether it's multiplication or division. We can take them from one radical to two radicals, or vice versa. So now what this allows me to do is actually take the square root of 9. The square root of 9 is 3. I'm using those perfect squares. Now I'm going to look at 2. 2 is a prime number, so it's not going to simplify. And so here's what I have for my answer. So if we take a look at what we had before, and if we take a look at our rules, is there only one radical in the answer? Yes. Is there a fraction in the radical? No. Under our radical is the number 2. And is there a radical in the denominator? No. I've got 3. And so what we've done by using this method is we've taken care of those first expectations of what our radicals should look like in simplest form when it involves division. So we go through here, we have square root of 120 over 121. I'm going to split that up into square root of 120 divided by square root of 121. The square root of 120 is 11. If you need to check your denominators by taking the square root in your calculator, then do that. And so what I'm going to do now is take this 120. Now, when I had 2 in the previous example, it was pretty easy to know that 2 didn't simplify because it's prime. 120 is not prime, and I could start as simple as 2 times 60. Well, now I have 2 times 30, so there's a pair of 2's. I can't stop because 30 is 5 times 6. I can stop with the 5, and the 6 is 3 times 2. So if we take a look at here, this 120 does simplify. The 2 gets pulled outside the radical, and what stays under there is 5 times 3 times 2, which is 30. Now, when we look at this, what we have outside, we cannot divide. 2 does not divide by 11. So we're going to leave that as our final answer. All right, method 2. Divide the numerator by the denominator if the quotient would be a whole number. So I'm going to look at what I have here, 22 and 11. If I did 22 divided by 11, would that give me a whole number? Well, it sure would. So I'm going to now take 2 separate radicals and put them under 1. 22 divided by 11 is 2. And as we saw earlier, 2 is prime, doesn't simplify, so there's our final answer. Does 6 divide into 48? Yes, it does. So I'm going to write this as the square root of 48 divided by 6, which is the square root of 8. Now keep in mind, simply because I've gotten rid of the fraction or I've gotten rid of 2 radicals doesn't mean that I'm done. We still have to simplify this. So 8 simplifies into 2 times 4, which is 2 times 2. So there's a pair of 2's. This comes out. So I actually end up with 2 square roots of 2 on my answer. And as before, we can check these on our calculator. So if you type that in as the square root of 48 divided by the square root of 6, the decimal equivalent is going to be the same as 2 square roots of 2. All right, let's take a look at our last method. So now what we're going to do, all right, so if you notice, the last couple of things we've done have been pretty easy, pretty pain-free. It's just been some division, some square rooting. Now what we're going to look at is this third method is what we're going to actually use when neither one of those options is available. So if we take a look, we have square root of 5 over 7. The first thing we're going to check and see is 7 a perfect square? No. Then we check and see, does 5 divide by 7? Well, no. So I don't have a way of getting rid of the square root, or getting rid of the denominator to get rid of the fraction. I don't have a way of getting rid of the fraction by division. And so what we're going to do is we're going to multiply both the numerator and denominator by the denominator. And so what that is going to do is that's going to give you a perfect square in your denominator. Well, the cool thing about multiplying by 7 over 7 is it's just the number 1. And so I'm not changing the value of my number, I'm just making those numbers a little bit bigger. So I'm going to have the square root of 35 over 49. Now I can go back to that very first question. Is your denominator a perfect square? Well, now it is. So I'm going to separate these. The square root of 49 is 7. And now I'm looking at the square root of 35. Well, 35 takes two prime numbers, 5 and 7, which don't break down. So it's going to stay square root of 35 over 7. Now this does not simplify because 35 is considered a radical, 7 is an integer, and so those are not like terms. I can't do division, and so that's where the problem stops. Let's take a look at example 6. Even though it's separated as two radicals, I'm still going through my rules, my options. Is 2 a perfect square? No, so I can't take the square root of 2. Does 3 divide by 2 and give me a whole number? No. So what I'm going to have to do is write this as one fraction multiplied by 2 over 2. That gives me the square root of 6. Gives me the square root of 6 over 4. Now don't simplify that, ladies and gentlemen. Keep it as it is, because what we want to do now is separate square root of 6 over square root of 4. Perfect square becomes 2. 6 is 3 times 2, both prime, so it stays square root of 6 over 2. These will always be factors of each other, but we're not going to do division because they're unlike terms. All right? If you've got any questions, we'll go over those tomorrow in class. Have a good day.